Hey, what's up, guys? This is Chung here again. So today, LeetCode 1151 minimum swaps to group all ones together. Okay, so you're given like a binary array data, right? So where it only consists of either 0 or 1. And your task is to return the minimum number of swaps required to group all ones together in any place in the array. Okay, so with the swap means that we simply swap two numbers, right? So for example, in example one here, the answer is 1 because obviously we can either swap this, these two, right? Or we can swap uh these two, right? Basically that will result to one swap, and this is and all ones will be together. And so we can also try to swap everything into the middle here. That will basically need two swaps. That's why the answer is 1, right? So, and yeah, so in example 2 here, obviously, we don't need to do any swap because all ones are already together, right? And then here are some more examples. And the constraints is it like 10 to the power of 5. Okay. So, I mean, yeah, there are like a lot of hints here, but don't mind. Ignore those hints. So at the first glance, actually, this problem is maybe it's a little bit like tricky to come up with a solution because if we trying to solve it from start to the end, if we try to solve it from the original state and try to find the end state, right? So that would be like, we have so many options here, right? Because we can swap any numbers, we can swap any two numbers, but which one are the ones we want to do, right? So how can we solve it, right? I mean, if we look at this first examples, actually we might already have like a hint, so which means that, let's say we have uh, this number of data, right? And let's say we have, you know, actually, the final state, the final state depending on how many ones we have in this data, right? Let's say we have 3 ones. We have 3 ones in this data, and then this is the total length, So how many possible final state we might have, we might have 3 ones at the beginning, right? And then we might have 3 ones here, right? And then again 3 ones here, and then here, here, and here, right? So now it's becomes very clear that actually this one is a sliding window problem, which means that because we can only have this many of possible final state we have, because we in the end we need to uh, make all those ones stick together. That's why there are only this number of possible end state that we can get by doing any number of swaps, right? And given like a state, right? Given like a state, and we can easily get how many swaps we need to get to the final state, right? Because let's say, for example, we are at this current state here, it's it's in this section of the original data, right? So basically, how many swaps we need to make to get to this final state? Obviously, it's the how many zeros we have in this section, right? If we have 0, 1, 1, obviously we need one swaps, because we need to swap it means that there is a 1 out somewhere outside of this range here. It means that we will need to make one swap, right? So if we have two zeros, right, it means that we're gonna need two swaps. So now the problem comes turns to be how can we efficiently calculate the basically the total zeros, right, in the in the given sliding window status. Obviously, I mean we can use a two pointer, right, which means that, the first pointer is the current one, and then the second pointer is like here, right? So every time when we move like the right pointer to the next state, we we, if the new one is a zero, we increase the zero count, right? And then meanwhile we're gonna remove the last one, right? If the last one is zero, we'll also need to decrease the zeros. Okay, and that's how we solve this problem, right? And okay, let's get to the coding then. So first thing first, we need to get total ones, right? So it's going to be a data dot count one, right? Because this total size, actually, this is the size of the sliding window, right? Okay, and then let's do and then we're gonna need like the current zeros, right? Because we need like the starting point, which means that our starting point is the first state, which means that all the ones are at the very beginning, right? So that's why we have to do the first for loop here, total ones. Okay, so we enumerate this many of ones, just to get to the starting point. Basically, if the data I equals 0, right, it means that we're gonna increase the current zeros, right, by 1, right, and then we can just simply assign this one to the answer. Basically, our answer will start from here, right, because that's gonna be the first state, and then we're gonna move our sliding window one at a time, and then we're gonna update the current zeros, because at each state the current zeros will be the number of swaps we need, right, for that state. So which means that we're gonna move our right pointers starting from the total ones, right, and then n. Because let's say if the this one's pretty obvious, right, since we're going to start from the next one, which is the total ones. So so we check the new numbers of the sliding window. If the new number is 0, right, we increase the zeros by 1, right, and then we also need to remove the element from the left pointer, right, because let's say this is the I, right, and then the size is 4, right. So when the right pointer pointing to here, it means that we need to remove this one out, right? So and the index for the left one is what? It's the data, right? I minus total ones, right? Because total ones is size of sliding window, and if the ones we're removing is 0, it means that we also need to remove 1 zeros from the zero counts, right? Okay, and then the answer swaps, right, for the current state will be the current zeros, right? So and we just need to update the final answer to get the minimum values out of all the states. Okay, and then simply return the answer. Yep, I think that's it. So run the code. Oh, I haven't defined the n yet. Okay, data. Okay, 1 submit. right? So it's accepted. Because as you guys can see, even though we have a pretty big constraints here, but since we only have one for loop here, and to get to calculate the swaps, right? The swaps for the current sliding window is only O of 1, since we're like only checking the new number, and basically we're only checking the right pointer number and the left pointer numbers once. Okay? And the time complexity is like O of n, right? And the space complexity, actually it's O of 1, because we're only using this one like variables to hold the current zero counts. And yep, I think that's it, right? It's a very interesting like idea, solves problem. Basically, we are, instead of starting from the initial state and trying to figure out the end state, we start from the end state, right? Because with the end state, it becomes much easier for us to calculate the swaps, right? Cool. I think that's it for this problem. I'll just stop here, and thank you for watching this video, guys. Stay tuned. See you guys soon. Bye bye.